I'm the Scholl Chair in International Business. I run the International Business Program here at CSIS. We welcome you for this conversation on intelligent transport systems. Professionally, I'm a Program Director at CSIS, but personally, I'm a car guy. I'm a hobbyist, an enthusiast. I clog up my garage with a 50-year-old automobile on the side that nobody else gets to use. I subscribe to about 5 car magazines and read about 6 different blogs. So I'm immersed in the industry and the hobby, and am continually impressed. While I'm at heart a vintage car guy, I like to be able to turn wrenches and do the things that my regular driver no longer needs. But I follow the industry and am consistently impressed by the degree to which technology is applied in ways that improve the experience for the driver, improve the safety and efficiency of the automobile, and improve the operating environment for cars. So it's every time I go out in the garage and look at my 50-year-old collector car, I marvel at how far the product has come in that amount of time and how much future potential there still is in applying technology to the solutions associated with driving. In today's world of global value chains, the city is the new factory, and urban transport is becoming a more critical element of efficiency of all supply chains, and creates amazing opportunities for productivity and efficiency, as well as the experience of people in the transit system and the safety and health of those experiencing the system. Today's program will cover some of these issues, and my role here is just to thank you for coming and to turn the program over to my CSIS colleague, Chris Kane. Chris is a senior advisor on technology issues, and we'll kick off the program and introduce our speaker. Thank you for coming.
Thank you, Scott, and good afternoon, everybody. We have in my opinion, a very leading edge topic here today that will look at our world and our society in many different dimensions. I think as you saw the invitation that came to you, the paragraph that Scott just paraphrased was very multidimensional. It's about transportation, obviously. It's about individual choices. It's about environment. It's about energy. There are lots of things. And we are really very fortunate today to have one of the world's leading technologists and auto executives and a real visionary for us to listen to and to learn from about the future of our society and how intelligent transportation systems will be very much a part of that and redefine how we live our lives as well as what we invest in, and how our societies will find new business models that have the potential of creating new economic development opportunities for people around the world and countries around the world. So let me take a minute and introduce Dr. Watanabe. He joined the Toyota Motor Corporation in 1967 upon completing his postgraduate studies in aeronautical engineering at Kyushu University. He became the chief engineer responsible for the Toyota Crown, which, as if you know, is the largest and best-selling luxury vehicle in Japan, and was named to the board of directors of Toyota in 1996, where he was responsible for and directed the research and development work on hybrid and fuel cell vehicles. In 1999, he was made managing director, and during the years where he was managing director, he was responsible for just a few things: R&D, product development, environmental affairs, quality control, information technology, and intelligent transportation systems. So he has a few pockets of expertise from which to speak to us today. He has, in June of 2005, he became the senior technical executive for Toyota, and since June 2009, he has been the chairman of the Intelligent Transportation Systems Japan organization. And this year, as Japan and Tokyo host the ITS World Congress, he is also the worldwide chairman of the Intelligent Transportation System World Congress. So I'd like to, before I ask him to come up and speak to us, I have one housekeeping announcement for you. At your chair, if you don't have it on already, you see a translation device. Dr. Watanabe will be speaking in Japanese. For those of you who understand Japanese, you don't need to use the device. For those of you who need some assistance with Japanese, you want to go to channel 1. And since these are digital translating devices, you will see it says English, 1 English. So that's pretty simple, okay? If you happen to want to hear the Japanese, the English to Japanese version, then you want to go to channel 2, and that says Japanese, okay? That's pretty easy to follow. So at the conclusion of Dr. Watanabe's remarks, we'll open it up for a Q&A session. I ask that in that session you introduce yourself, state who you are and who you're with, and we want to make sure we want to use the microphones so we can capture this because this event is being streamed live and for the benefit and the courtesy of our translators who are helping us out tremendously by being in that booth and making this intercultural, interlingual opportunity productive. So thank you for coming this afternoon. Dr. Watanabe, I'll turn it over to you.
Good afternoon, everyone. I am Watanabe from Toyota. Today, I'm very happy to have this opportunity to discuss with you. I'm very honored. Chris gave a very detailed introduction of my background. I have been with Toyota for 47 years. So you wonder, gosh, you've been working in the same company for that long time? You might be suspicious, but I've done many mistakes in the past. And if you have any questions, I can answer to them as many as possible. But the company, perhaps, they thought that if they fired me, I might give trouble all over the places, and so perhaps they kept me for a long time and they kept paying me for that. Well, today I would be talking under this title that's shown on the screen. This ITS stands for information. What it means is that the combination of the information technology and the communication technology, we still have many challenges in the transportation system, and we try to solve many of the problems through this. So this is that sort of a general term for that. Now let me start. Back in 1886, Carl Benz made a great invention. And for the first time in the world, the gasoline-driven automobile run on the public roadway. And the advertisement verse says as follows. It doesn't feed while in the stall and only drinks when works the call. I think it's wonderful. It was an excellent invention, and I think this verse is quite nice. At the beginning of the 20th century, the GM invented the electric starter, and Ford also made it possible to mass-produce vehicles and reduce the cost of that. All these technical innovation has raised the value of the vehicle. And at about the same time, the first proposal was submitted to establish the highway system that would go over this big continent. Automobile technology and highway network establishment, these two put together, this brought about a synergetic effect, and the United States has become the richest country in the world that world really was envious of. As shown on the right-hand side graph, globally and also within the United States, the expansion of mobility and the development of world were put in one. Automotive society and its development, this really became the tool and increased the convenience of the mobility and the freedom of the world. Economic development and social and cultural diversity really were helped by this to expand. Afterwards, we've experienced various crises in the automotive society, but we were able to overcome them using appropriate technology. However, today, when we look at the challenges of the traffic society in the world, traffic accidents and traffic congestions that we really experience at many cities in the world, and demographically, societies are getting more aged. So we are faced with these issues. So what is the next innovation in the new mobile society? Now, I would like to talk about them. What are required for innovation? First of all, it is the creation of new values and goods, infrastructure, people. We really have to approach them in a comprehensive manner. And finally, this is the initiative to transfer the power from the state and country, nation to city or to the citizens. Well, in order to accelerate the innovation, we really have to call for the direct participation of the cities and the citizens. This video was taken from the smartphone. It really shows the flow of people in Tokyo. That very unfortunate East Japan earthquake hit on March the 11th, 2011 at 2:46 p.m. Please look at the digital watch on the right bottom side. Please look at the time. You can see how the movement of the people drastically changed at 2:46 p.m. Please start the video. Thank you. As you just saw, if we utilize the big data, we could save many lives at the time of disaster. This video really shows that implicitly. Now let us look at it more specifically. Let me introduce to you some of the examples of the ITS utilizing the big data. Using those roadside sensors, the traditional traffic information system would collect data. But recently, on top of that, we are utilizing GPS information and the car speed information. Those Prove information system has become more prevalent. So those traditional traffic information is very reliable. However, it lacks the timeliness. On the other hand, the Prove information still has some uncertainty, but it really gives us detailed real-time information. So by combining those two, we could prevent accidents, facilitate the flow of traffic, and reduce CO2 emissions. However, when I talked about this integration of big data and took it to the agency of police, they said, just so bluntly, these private sector uncertain data cannot be used to the signal control or traffic control. I mean, what kind of effect can we expect from this? It was really cold, the way they responded to us. Any time or in any country, I think the police people have very hard, rigid head. I'm really trying to work on this development of ITS and leading this NPO organization, ITS Japan. I'm the chairman of that. ITS Japan was really trying to figure out and conducting this effect calculation of the private sector big data integration, and that earthquake happened right in the middle of when we were doing it. Through this natural disaster, we learned something extremely important and indispensable for the society. That is the power of people try to help with each other. From our friends in the United States, we received a very huge, warm support, and that helped save many of the lives in the area where the disaster hit, and we were really encouraged by your warm heart. I would like to take this opportunity to thank again for your Operation Tomodachi. Thank you. Immediately after the East Japan earthquake in 2011, ITS Japan put together the probe information from the private 4 companies, and we added a governmental regulation of the roadway management, and we've overlaid it and shown it on our webpage. These were possible because we were collecting data from the running vehicles that was going on those roadways, and we were able to show where you could go and where you could not go. So at this time, for the first time, people really felt the applicability and the value of real-time proved data. This was really an example of a new value creation. So this effort was very much thanked by the police. They said, thank you, this really helped to save many lives. This was the first time in my life that police thanked me. So this really example triggered the possibility of putting together the public data and private data on a common platform. During the normal time, this will give information regarding where the accidents were occurring or the amount of CO2 emission and make it visible information on the web. When the disaster hits, this can be changed into an emergency mode. And we're really working on this with the Toyota City. This is a very comprehensive approach, and also this is really using citizens' eye level and citizen participation. This is really the transfer to the initiative to the citizens.
Let me now talk about automated driving. Thanks to advances in recent years in technology, now it is possible to have an understanding using radars and cameras to have an understanding of the surrounding environment of the vehicle and its driver. Automated driving technologies to assist the driver in controlling vehicle movement will be increasingly deployed as we go forward. In order to realize advanced automated driving, it is essential to have vehicle-to-infrastructure or vehicle-to-vehicle ITS. In order for us to anticipate approaching vehicles in the blind corner and anticipating other risk information by making use of ITS will guarantee that or realize safe and comfortable travel. There is the autonomous type of safety system where inter-vehicle distance, speed, and lane keep controls aboard the vehicle is used. There's the coordinated type of ITS that warns obstacles ahead and provides merge assistance. When these two converge in an advanced fashion, an advanced driving assist system is realized, which leads to full automated driving. And let me shift gears and let me talk about automotive safety data. These show worst rankings created by the WHO showing what brings harm to humans. In 2004, road traffic injuries ranked 9th. There were 1.2 million fatalities in that year. In 2030, it's anticipated this will climb into the 5th position, and running a simple calculation, it appears that the fatalities would reach 2.4 million. So reducing fatality is a very urgent issue. This is a plot that was put together by the OECD, and this looks at road traffic fatalities by country per 100,000 people. To the left, you see the yellow bar, that's Japan, and the 4th yellow bar from the right shows the United States. You can see that even amongst the industrialized countries, these figures differ depending on the type or the situation of transportation conditions in the respective countries. And on a global level, it, in any case, shows that road traffic fatality reduction is a major issue. There are many important features for automobiles, but safety certainly is our number one priority. In order to achieve traffic safety, there are three factors that come into play. There needs to be a holistic approach that involves the vehicle, infrastructure, and the human being. Currently, we're at A. And currently, there's a trial going on in Michigan. And if this system of V2V ITS is adopted, you will shift to B, scenario B. Based on our track record in using V2V, in the case of Japan, the fatalities total 4,411 last year, but we believe it will be possible to reduce the fatalities to 2,500. And that is, if the U.S. can adopt V2V ITS and its advanced variation of that, it will be possible to reduce the number of fatalities in the United States as well. And I'm hoping that good results come out of the Michigan trial. By adopting V2V ITS, the United States can become the envy of the world in terms of traffic safety. It is beyond this that we will have the world of advanced driving assist system and automated driving, where anyone can drive safely and comfortably as if they were skilled drivers. And I would like to see as soon as possible acceleration of these steps so that we can ultimately achieve zero fatality. Before the advent of the automobile, if you had a very well-trained horse, the rider, regardless of their age, could enjoy a safe trip. If we could inject the ability to anticipate risks into this, we would have an even more wonderful world of mobility. In other words, by integrating travel data and driving data of the respective vehicles and put it in the cloud, and by sharing these data, it will be possible for anyone to drive as a seasoned driver with comfort and in safety, and this is the kind of world that I wish to create. This shows millimeter wave radars and lane keeping assist. This controls lateral and longitudinal movement of the ITS, and this shows a test that was conducted. Please start the video. So there's lateral and longitudinal movement control. This is automatic control. The vehicle controls the lateral and the longitudinal movement of the vehicle. So this is the kind of movement control that I'm talking about. The next video, please. This is an experiment that was conducted by the Japan Automobile Research Institute, where in which V2V communication was used to permit a convoy type of formation. Please start the video. A formation of an intervehicular distance of 4 meters was used to explore the potential of this technology. It would be possible to reduce CO2 emissions by 18% by making use of this technology. Innovate automobile dynamics and put an end to young people not wanting to drive. There are two coordinated activities that are required, and one is to develop ITS basic infrastructure that would allow forecasting information, and also to have global standards based on the common understanding that the driver is the main actor in all of this, and there needs to be collaboration between citizens, businesses, and government. So safety technology that is not able to transcend borders is not usable. That means international cooperation is essential. There are many transport issues facing our world today. By making use of automated driving technology, big data, and ITS data network, by combining all of this, we are able to reclaim the safe and comfort mobility that was once possible when the automobile was introduced 127 years ago, where we'll have a mobile society in which the machine serves man. This will revolutionize freedom of movement and safety and advance industrial progress in our economies. And I believe this also will be an impetus to creating a world in which there's more direct participation by our citizens. What are the benefits that the United States, Japan, and Europe may be able to reap from ITS development and commercialization? As chairman of the ITS Japan, I like to be able to brag our technology, but each region has its own strength. Japan has the infrastructure that was invested by government, and the United States has its business models. Europe has its mature social systems, and each has its own forte. By making use of that and collaborating for standardization, it will be possible for each region to have its own policy and accelerate local investments and market choices so that common standards can be built that transcend the different regions. In order to provide a forum for ITS development, the ITS World Congress is being held in Europe, North America, and Asia, in these three different regions in rotation. This year, it will be held in Tokyo. In the United States, in Orlando, it was held in 2011. Next year, it will be in Detroit. In 2015, the venue will be Bordeaux. Automated driving and big data that I spoke about today will be taken up by the World Congress Board of Directors as a common theme, and international cooperation is to be conducted, and there's a resolution to this effect. We have Scott Belcher here, ITS America CEO. Mr. Belcher, yes, thank you. I'd like to join hands with Scott Belcher and launch a new Operation Tomodachi in the world of ITS to eliminate traffic accidents and to create a transport world that is kind to the environment is what we hope to achieve. Well, thank you very much for your attention.
Dr. Watanabe, an excellent presentation, very multidimensional, as Scott and I both said at the beginning. So we should have lots of dimensions from which you can ask questions or make comments. So I'm going to open up the floor now for people if you have a comment or a question. Please identify yourself, and again, please use the microphone. So if you can raise your hand, I'll call on you, and we can begin the Q&A process. All All right, let me take the prerogative of the moderator and ask the first question. All right. Dr. Watanabe, you talked about the promise of ITS. In your opinion, what do you think is the most important or the greatest benefit that the United States, Japan, and Europe and other countries in the world will see from the deployment of ITS? There are many benefits, clearly, but I'm just interested in your, and I think the audience would be interested in your personal perspective, given the years you've spent in the industry and your knowledge of of societal issues about what the most important benefit is from the deployment of ITS.
As I said earlier, the most severe issue, of course, there are many of them, but I think it's the human lives, particularly in the developing countries where they are now getting into really using more and more cars. And they are faced with congestions, and many of the lives are lost. So if we are just to look at the linear extension of what we're doing, there is really not a bright future for cars. The most important priority is how to protect human lives. And how can we innovatively reduce the loss of human lives? I think that's the ITS. I mean, definitely we can go forward step by step, however we can make a progress. Did I answer your question?
Thank you very much.
Okay, please identify yourself and use the phone.
That was a very interesting presentation. Thank you very much for that. My question is, there's been a lot of innovation in the cars themselves and the technology that drives them. There's been a lot of technological development that you described with the cars themselves. Has there been an equal progress in the technology in the road system itself on which these cars are driving? And if so, what?
I'm sure, naturally. This is not so much of my personal view, but this is the data published by DOT. In the case where there is no communication on the roadside, and compare it to the ITS applied situation, and lastly, the control is being done there. I think this is what they are suggesting, the DOT. If there were anybody in the audience who are somewhat related to DOT, you feel free to supplement my comment.
One of the dimensions of this issue that you've asked about is, are societies and governments and communities ready to invest in the infrastructure so that the capabilities of the vehicle can produce the kind of benefits that we see, talked about by Dr. Watanabe. And I think that's one of the interesting topics to this, which is at what pace of change will certain countries pursue this vision? At what pace of change will certain communities adopt these technologies and embrace them so that they can be used for either societal benefit or competitive advantage? And so there's a very interesting selection of choices that leaders and citizens will have to make together. And so it won't just be a top-down or a bottoms-up approach of change. It will actually be both. And I think Dr. Watanabe has some thoughts on this, and I'm going to give him the opportunity to respond before I go to the next question. And Scott, I'm coming your way.
I may have missed the question, but what was the point again? I told you I make a lot of mistakes.
I think it was, is the infrastructure and the environment ready to embrace and to benefit from the technological advances that are becoming more prevalent in the vehicle? Is that correct?
Okay, understood. Certainly, I think we are ready. ITS, as I said, now having this World Congress at 3 areas in the world, rotating, and we are trying to discuss what level of technology we have reached, what kind of implementation has been done, and what sort of effect are we getting. And so we are sharing that information amongst those 3 regions of the world. Furthermore, we are trying to figure out what sort of things do we have to further change. Safety is one, and furthermore, is the current infrastructure is already outdated. I mean, given the road situation and congestion, environmental issues, those are the challenges. In Japan, we had an issue that some upper structure in the tunnel fell down and caused a very tragic accident. We have to make this infrastructure a lot easier to do the maintenance work. And it's, of course, would contribute to the safety, and also it would keep a better balance of the investment and the safety that we can get from that. So I think many of the studies are being done in various countries. For example, if we are to get those through the probe data, we can collect a certain collision situation, and if the certain amount of data exceeds certain values, then we have to revisit the conditions of the roadway and see if we have to improve it or to conduct some extra maintenance work. So those structure is really become possible by utilizing this ITS, and that's one application to contribute to the maintenance work of the roadway. And furthermore, not just the infrastructure, but this is really the administrative or executive branch. For example, where is the water pipes? Where is the electricity lines coming? All these information, or where's the maps that is based for the property tax calculation? Can we really put it all in one? I mean, then we can reduce the administrative cost. These ITS can be applied to many other different ways. I think we really have come to a point where we have to deflect or change our point of views.
Scott Belcher with ITS America. Dr. Watanabe, can you talk a little bit about the level of deployment of ITS that currently exists in Japan with VIX, with electronic toll collecting systems? We're not just at the cusp, we're actually in the middle of a deployment cycle.
Yes, well, thank you very much for that. Well, ITS was started with a navigation system and communication system that Mr. Belcher just mentioned came out later, and that was in Japan. That was at the beginning of 2000. It was called VIX, and it was a stationary sensor system. You had these sensors embedded in the road, so you can count the number of vehicles, as well as the vehicle speed could be calculated to anticipate if there's going to be a congestion ahead. And this is being deployed nationwide, except for unpopulated areas. And then subsequently, there was probe data that came up, and using probe data, respective automobile manufacturers edited their own customer vehicle data, and that is being provided to our customers, to our citizens. And in 2010, the demonstration project was completed, and this had to do with a highway system. Sometimes you don't see a car ahead of you, and the oncoming truck may strike such a vehicle that you cannot see. This happens quite a bit. So the idea is to be able to anticipate that there is a parked vehicle ahead. This kind of information that gets fed to the operator of a vehicle was the content of this demonstration project, and we saw a reduction in 30%. There was a 30% reduction. Rather, there was a 70% reduction in the occurrence of accidents. And the test was completed in 2010, and this was deployed nationwide on the national highway. So this is something that's actually occurred already, and we anticipate that there will be a big impact from this. And looking at the situation in the U.S., I mentioned earlier that the trial in Michigan will be completed in August that makes use of V2V, and the United States plan to start this V2V, and I look forward to the United States adopting this system to achieve good safety in transportation. Did this answer your question, Mr. Belcher? Well, thank you very much.
Yes, sir.
Hi, my name is Bernie Lee. I'm a graduate student at Seton Hall University. My question is about the automated system itself and the safety measures. You mentioned that there'll be a lot of cloud information sharing to share with the vehicles, and there will be information between the vehicles. But it seems that with all this information being put into the cars themselves, that it would make the driver it would make it less necessary for the driver to stay aware of what's going on around him. And so what happens if the system fails for the driver? It seems that it might set up a much more catastrophic event because you have less drivers who are paying attention to what they're doing because they're waiting for the system to give them a response that says you need to slow down or it's going to slow down for you, and they can't override it. So if there's something like an earthquake, a tornado, or something that shuts the system down, it seems that there could be an opportunity for a much more catastrophic, actually not a zero fatality situation, but something much worse.
May I? Now, the question that was asked is a great question. I think that's a very good point that you brought up. And I had anticipated this type of question, so if I could show you the slides. It shows the different levels of automated driving from level 0 all the way to level 4. Now, it's important to think about what you just pointed out as we engage in research and development. Or certainly, as you pointed out, it could be a risky proposition. And it's in small print, so you might not be able to read it, but it says level 0. This means that there's no automation. It's a very primitive state. Level 1 makes use of ABS, ACC, and that type of thing. Level 2 has Level 2 has ACC and lane keep control fusion, where they have a combined system that we talk about this in terms of lateral and longitudinal control. That would be level 2. And level 3, as I mentioned, is where ITS is being utilized, where you can anticipate and provide information to the driver of the situation that will be encountered 10 seconds out. And level 4 would be full automated self-driving. And what will happen to the average driver? You leave your home, you're riding on the roadway, so that's level 1. And once you enter the expressway, it's level 2, where you have advanced information about what's to come, and then that brings you up all the way to level 3. But before that, in green, that shows where we are today, functionally. So level 1, you enter the expressway, and it says emergency stop. Now this means if a deer jumps in front of you, or the vehicle in the next lane cuts right in front of you, it may be that the vehicle may just brake automatically, but that may not be soon enough, in which case the operator has the ability to override the system and manually press on the brakes. So you go from level 1 back to level 0. If the blue evolves, you can reach level 3 or level 4. And even in that scenario, regardless of what level you're at, it could be up to level 3. To the left, can you put the pointer more to the left? No, you've gone too far. Yeah, well, that's too far. You're not good at operating this, are you? You're not a very good driver. So if you're driving at level 3, okay, so you're driving using level 3. Okay, you're traveling, and there's a deer that jumps right in front of you. If you let the vehicle take control, you have a sense that you're going to hit the deer. Then you brakes, you apply the brake, and then drops to level 0, and then the system comes back on. And level 4 is where you have infrastructure ready to support, where full automated driving is possible. So in an ordinary situation, from level 0 to level 4, even if the system is evolved, we will go back and forth. But as we see advances in technology, the green scenario will be taken over by more blue. Or we may go, there'll be a larger percentage where you're driving in the blue. So what that means is the question is, how much can we reduce human error-related accidents? So if the system fails, can we design a system? Can we have good human-machine interface that will allow the driver to go down the steps all the way down to level 0? So there is always a risk, but we have enough wisdom to overcome some of these potential risks. Thank you.
Yes, in the back.
I'm wowing. Yes, Britt Minchell from the Renaissance Institute. As a social psychologist, the only situation, I think this is great, but I look at this level 0 through level 4, and I can easily see us getting to level 2 with no problem. However, if we get to 4, it would seem like everyone on every road would have to be doing the same thing, or if the deer jumps out and I hit my brakes, you might have a catastrophe on your hands with everybody going on automatic and one person is going to go back to manual. We could never mix that, right? Thank you.
That too is a wonderful question. I feel that I really dream of this kind of society every time I go to bed. There are times that I can't go to sleep because you never know what's going to happen. And in the worst case scenario, what might happen? I mean, just exactly that person who asked the question described. Where the infrastructure is completed, then the system, whether or not the system is complete and perfect, I mean, someone ought to be in control of that. Someone ought to know that. And you really have to look at the total a system, and the order in there has to be recognized and it has to be controlled. I mean, without that, it won't work. So it has a very high hurdle. However, this is a kind of a technology, and we never thought that we could see color TV when I was a young boy. I mean, that became possible. So this is something that, you know, a vision that this is a wonderful dream capability of humans, and I think that's something that we really have to pursue. We do lots of research and development, but this is a very high hurdle, as you pointed out. So what I'm talking about is even in a lower level, if we can do it steadily and carefully and well, we still have a lot of room to reduce the traffic accidents. If so many people are afflicted by the traffic accidents, then we should really, you know, reduce it. I mean, do things that we can do now. And then also keep a big vision dream ahead in the future. So we really have to do both bottom up and top down. That's the clever way to do. Thank you.
Yes, sir.
My name is David Venlet, and I had a recent career in defense aerospace acquisition. I would just like to hear your thoughts with your own aerospace training that was referenced in the introduction. Across the boundary of this for airspace, airplanes, intercommingling unmanned vehicles, manned vehicles.
I think we're getting feedback on the system.
Is that okay? Is that better?
I think we have a technician. Can you,
Is that better? Yes, sir. Thank you. I apologize. My name is David Venlet. I had a recent career in defense aerospace acquisition. I'd like to hear your thoughts, sir, to take this to maybe the domain of airspace, commingling manned, unmanned vehicles, the technologies, the principles, the social aspects would be relevant. I'd love to hear your thoughts.
I did some master's degree in aeronautical engineering. It was over 46 years ago, so it was a long time ago. So I really don't know what's been happening at, I mean, the cutting edge. But for example, GPS system, if I hear that it is going to become much more precise. We have a Jackson Aeronautical Research Institution or Research Center. That is the launch and also rocket related technology, and whether a research satellite, if you launch 7 of them, for example, you can really, currently the GPS system has the precision of several 10 centimeters, but it can become 5-6 centimeters in grid. Then movement of the vehicle can be watched from the space, and you can really see how the vehicle behaves in the traffic light, and you know, also looking at the red light coming on, and then you can stop the vehicle automatically. I mean, is that something you were talking about? Did I answer your question? Well, if you have better examples, please share with us.
That's fine.
いいですか。ありがとうございました。
Thank you. 他の
wait for the mic, please, and introduce yourself.
Hello. My name is Joe Goldman, and I'm with Project Interchange. I have a question for Dr. Watanabe about why you think this money, because it would take a significant amount of money to go into automated driving systems, which could clearly save many, many lives. Why this is money that is better spent here instead of in mass transit opportunities.
これもいい質問ですよね。答えるのが難しい。 かし、
Wait one second, please. We're not getting the English on channel one.
I'm sorry. Apologies from the interpreter. That's an excellent question. It's very hard to answer that question. However, this is something that we really have to study very hard. The biggest thing is, if there is a very high density of population, I think this public transportation would work. But if you are looking at the area where there are not so densely populated, then it won't work. So then the discussion is, why is the car better? This automated driving technology is really depending on the millimeter wave and a V2B or VTI communication. And these technologies can be used besides automated driving. It could really reduce the congestion or also to reduce the CO2 emissions. And also, right now, the younger generation people are sort of getting away from cars. And you are a young person. Are you not interested in cars? So you are shaking your head, so perhaps you like the cars. Thank you. But globally, there is a certain trend, particularly in Japan, younger generation people, and also in Europe, young people, perhaps to a degree in this country as well. They like a computer or a smartphone. They prefer those to cars, which saddens me. But now, automated driving is something that humans so far had to practice, study, so that we could maneuver the machines. But now, the machines will come to adjust itself to us, to the humans. So that's how we can reduce the accidents or to reduce the human errors. And even aged people can drive safely and properly. Now, conversely, this is how I feel. For example, we can make the vehicle or automotive driving more fun. If you want to drive it more aggressively, then we can adjust the setting of the vehicle to such a driver. For example, if you want to go the windy road, it's much fun. And when you want to do that, when you come into the curve and you reduce the speed, you slow down, and at the corner point, you want to push in the gas again, and that's the basic maneuvering. And if the ordinary people are to do it, maybe it's too late to brake, and they tend to brake too suddenly, and the acceleration is a bit delayed. But how the Ailton seller did that, I mean, if we take this data from the big data and compare it to your own data, then you can change. So you can use Alton Center as your teacher, and you could even do better than him, and you might be able to do that. So that's an example. I mean, that this kind of a technology allows you to do that. So in a way, you really have to, this would allow to increase the attractiveness of driving from the eye level of each individual driver. Yes, of course, we want to increase the number of mass transit. I think that's needed in a very populated area or long, distance traveling. I think both are needed. Thank you.
I think we've come. Finish up with thanking Dr. Watanabe for his remarks and his vision. And in particular, there are many elements of this exciting future that he described. And there are many for us as society and as individuals to aspire to. But I have to say that the one element that I would like to aspire to is the opportunity to have a policeman say thank you to me one time.
Thank you very much.
So please thank Dr. Watanabe, and thank you for coming.